There we are. Okay, cool. I hope you guys can hear me okay. I'm in a different place, so I'm not hiding my screen right now. Or I'm not sharing my screen, I am hiding it. Any questions before we get started? You guys had some reading to do, working on your ideas for your wearable. Hopefully it'll all start making more sense as we continue. Today I'd like to go through, kind of want to go through the stuff that you guys went through in the handbook or the Arduino book. So I want to kind of go through that I consider are more important than others. You guys are supposed to all kind of go through it, so some of this information seems familiar. You guys are supposed to download the Arduino software, so we can do that a little bit today. And then on Tuesday, I want to solder. So Tuesday, I would like everybody to kind of figure out a place that they can solder. You guys all have a fan. You should all have a fan in your kit. And you can just make sure it's charged up. So it has a USB plug. There's a USB charger that you can, plug into your computer or plug into a wall wart or something, and you can charge up those fans, or you can plug them in and use them. But I think if you charge them, then you don't have to worry about cords and stuff. So you'll need your soldering iron and that whole setup, and then you'll also why don't I go ahead and take a look at some stuff on my screen here? Give me a second. Let's go to Amazon. Okay, let me share here. Let me know if you cannot see my screen, but you should be able to. So let's go to orders. I'll just look at my past history so we can look at the, let's see here. So soldering, let's see what comes up. So you guys are going to have a couple things in your kit. One of those things should look like this. It looks like an old garbage can or something, like a miniature little garbage can. This thing's, I don't know, 4 inches, 5 inches or so in size, and it has a brass, looks like a Brillo pad. So you're going to need that for soldering. So you're basically going to stick your soldering iron, the tip of it in there, and put it in there like a pencil, and kind of move it around back and forth like you're trying to clean the tip off. We'll go through all that stuff on Tuesday. But make sure you have this ready. You make sure it's got that little Brillo pad in there, this little metal thing. And that is a soldering tip cleaner kind of station. And sometimes you'll buy these soldering irons and they'll come with this little soldering setup. But I had to buy them separately because the ones I bought didn't come with them. So then you have you have a soldering iron. And it looks like this. So it's got this little coiled up piece of metal. That is where your soldering iron goes when it's hot. So that kind of acts as not really as a heat sink, but a little bit of a heat sink, but more as kind of a place for air to get in there and cool the thing off so you don't burn anything. And then there's a sponge in there, so you'll have to get that sponge wet like right before class. And maybe your setup isn't a place that you can do in class. So we'll talk about that in a second, where and what you'll need for all this. And then it has a pen looking like a handle. It looks kind of like a pen with a metal tip on it. And that plugs into the power unit. The power unit's got 1 to 8. It doesn't tell you the actual temperature on that. So it doesn't say like 400 degrees or whatever it is. So we'll have to kind of play around and adjust and figure out the heat. I haven't used these soldering irons yet. I use the one that we have in the studio, but I'm going to troubleshoot it with you guys so we can work out any issues. So what we're going to have to do for Tuesday is make sure both of these things are ready. You also have a little bit of flux and solder. So the flux is this yellow looking stuff. It looks like it has like little fibers in it maybe, but it's kind of a yellowy amber color, orangey yellowy color. And this is going to be for flux. We don't technically need this because the solder we have, you should have a little bit of balled up wire and a little plastic baggie. I think it's in a baggie. I don't think it fit in those little plastic containers. Oops, wrong thing. So you'll have a little bit of silver wire wrapped up, and that is right here. It's lead free, so it doesn't have lead in it like the old type of solder. So you're not going to get lead poisoning or anything like that. And it has rosin core in the solder. So in the solder, it has flux. So technically you shouldn't need flux, but I'm going to show you flux because I still use it. I think it helps me solder better. It helps me unsolder things better. It cleans the metal. I like to use flux even if I'm using a flux core solder. And I think that's it. Let's see. Yeah, that should be everything that you need for the soldering part. And then breadboard. Okay, so you guys should have one of these type of breadboards, and these are these plastic, I don't know, a few inches width and length, maybe, what does it say here? It doesn't say how big they are, but they're, 3 by 4 inches, 4 by 5 inches, something like that. And you should also have some little wires, not this many, but you'll have some long wires, some short wires in your kit. Don't worry about which colors they are. We're not really concerned about that right now. Just you'll have your wires, you'll have a breadboard, so you'll need that stuff today. I'm sorry, you won't need that today. We'll need that stuff coming up. But these are the type of things we're going to use once we solder up our little chip, our little Arduino chip. Then we're going to use this white breadboard. So we're going to be using this soon. Oh, it doesn't have those other ones in here. So you guys also have some little green breadboards. And they're not in here. So let me just search. Solderable. Let me see if that shows up. Nope. It's all right. You guys get to see me do some searching. Okay, popped up right away. So you've got, this is a 5-pack, but you have I think it's a 4-pack. So you should have 4 breadboards that are green. And they're kind of like the white breadboards. And I'll talk about what they are and what this all means. But basically, you're going to solder some pins in here. This is going to be your practice soldering. You're going to put some pins in here, and then you're going to solder them from the back and try to get your soldering skills down. It's going to be some practice. And then you're going to pull up, the Arduino, the Polulu. Is that the right one? Yeah, I think that's the right one. Man, how do I get this thing out of my way? Okay, so you're going to practice some soldering on these, and you're going to use in your kit. You also have what are header pins. Header pins, and they look like this. You've got a couple different kinds. You've got male header pins, where they're the pieces of metal that go through a small strip of plastic, and then you're going to also have female header pins, which have an opening on one side and little metal pins sticking in the other. So we're going to use these here, these ones that are mostly metal pins with a strip of plastic. So we'll be doing that on Tuesday. So just, just trying to get you familiar with some of the things that are in there. So these are header pins. And we'll solder these into the green breadboards for practice. So we'll put the short end in the breadboard, flip it upside down, and then we'll solder it on the back. But we don't need that today. And so what you guys want to do is, I would suggest, let's see about YouTube. I don't know if there's going to be any good videos on here or not. Soldering Safety. I'm going to tell you right now, the best thing you can do is work in a well-ventilated area or work in an area that has, a large amount of air volume, a lot of space, or has a fan, or you're outside or something. This soldering is nothing like silver soldering. So if anybody has silver soldered before, that stuff is super nasty. I've accidentally breathed that stuff in before, and you hack. It is nasty stuff. So you need to have a fan set up, especially to do that stuff. When I do my silver soldering, honestly, I do it in my living room watching TV. I have to do just a couple pins or even up to 20 pins, like your boards. I'm not sure how many pins those have. 1, 2, 3. Of course, my 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so about 20 pins. And that should take you about a minute at the most to solder. So this goes really fast. It creates a little bit of fumes as you solder it, and you don't want to breathe that directly in. So we're going to set up a fan. And you want to have the fan set up. I'm going to see if anybody on here. So I'm not going to go through these videos or anything like that. That's something I need to do on my own time. But I just want to show that you guys can definitely look up some of these. They're 2 minutes, 3 minutes long. And this is how to solder safely, This looks good right here. Are soldering fumes dangerous? And this is exactly like the stuff we're doing. So I would strongly suggest, I'm going to put this on for just a moment.
My name is Gary for the YouTube channel, Simple Audio Tips. Is soldering smoke bad for your health?
Paul, can you hear that?
Yeah, I can.
Okay. I'm just going to put this on for a few minutes and see what they're talking about.
Or some other toxic substance? Well, stick around and I'll find you out the answer and give you some tips on how to make soldering a little bit up of a combination of substances. 60% tin and 40% lead.
Ours does not have lead in it. So maybe this isn't a great video for that.
And also a wetting agent to aid solder flow called flux. Now, flux is added to help clean the surface that you're hoping to weld together. The metal must be clean of impurities or the connection's going to be poor. So to get a better understanding of what makes up the smoke that you see, let's start with some basics. I don't claim to be a scientist or a chemist, but I do remember a few principles from school. A substance, like a liquid, starts to give off gas when it's heated and begins to boil. Your soldering iron is usually set to the temperature of 300 to 400 degrees Celsius. So even though solder made from tin and lead may melt around these temperatures, soldering irons are just not capable of heating the metal to their boiling point to turn them into gas. Now, tin, for example, boils around 2,600 degrees Celsius and lead boils around 1,700. So by far the majority of fumes must be boiling flux. And that's what it's supposed to do. It reacts to the applied heat and it cleans the surfaces that you want to weld together. So is flux smoke harmful when you breathe it in? Well, interestingly, one reference stated that when flux is heated, it releases hydrochloric acid and other gases containing benzene, toluene, styrene, phenyl, chlorophenyl, isopropyl alcohol. So to put it simply, it's toxic and it also has a cumulative effect. So as with cigarette smoking, the effects of breathing in solder or flux smoke may not become apparent for many years, unless, of course, you develop some sort of asthma or bronchitis early. Now, I was working with Kathy on a sound installation in Brisbane, and I asked her why she was concerned about soldering smoke.
It can make you sick, and I was already getting sick, and I didn't want to add to it.
So, guys, take a look at this right here. You notice how this is her fan. So she has a fan set up, and you notice it's not blowing the smoke past her face. It's set off to the side or set up behind that it pushes the smoke away from your face. I'll reiterate on this on Tuesday, but that's one of the things you want to do is you don't want to set it up so that it's just blowing the smoke in your face or even past it. So a fan has, I think it's 10 times the blowing power than it does sucking power. So the blowing power of a fan is going to be, I think it's like 10 times more effective if it's blowing the fumes away than if you turn it around and try to have the fumes suck through there. It's just not as effective. I think it's because there's such a large volume of air being sucked into and a small volume being pushed out. But you want to set your fan up like this where you're blowing it away from your face. You don't want to be breathing this stuff in. Again, when I do this in my living room, I'm doing like a couple of these. The fume, I've got it going away from my face. In a case where I don't have a fan, I simply hold my breath and make sure that I'm out of the way of the fumes. If we're in the studio, we'd have a large studio. We'd have an exhaust fan that would suck those fumes right away from your face. But if you're going to be working remotely, you have to consider what you want to do with this stuff and if you even have a space to work. Was somebody trying to ask a question? I heard a mic come.
Chad, I just wanted to say something because I have been welding for quite a long time and I've been doing HVAC breathing. When you're soldering, try not to open your mouth when you're concentrating because if you swallow it and it goes in your belly, you can get benzene poisoning. I have ended up in the hospital because of it. it can make you have seizures and stuff. So just be careful, guys, when you're doing this. Make sure your setup is done before you turn on the soldering iron. So anyway,
go ahead.
Sorry, I just wanted to put my input because I don't want anyone to get sick. I've been doing it for a long time.
And so, guys, do you want to make, we'll talk about all this on Tuesday before we actually set up and soldering. So I want you to kind of look at all this stuff. Consider the guy in the video just was talking about how many different chemicals are in the flux. We'll want to look up a little bit more because the stuff he's talking about is more toxic than the stuff we're using. But the flux, I can't be sure what he's talking about. We're using a rosin flux, and the stuff he's using, even though it's an only 5-year-old video, we don't use lead in our solder. So that's kind of surprising. But as you notice, he talked about the metals themselves aren't the thing that you're creating the fumes. So I'm not as concerned about that as much as the flux. And so if you're doing this in a small room like your bathroom, unless you got some crazy awesome fan in there, I would not do it like that. You're going to want to do it in a bigger room. It's cold outside. It's getting cold outside. It's not too cold that we can't do some of this stuff. But you want to consider a garage. Even if you're in your basement and you're doing a little bit of soldering, it is nothing like welding. It's nothing like silver soldering where it's generating the amount of fumes that you're getting. You still want to take it seriously. It's not to put it to the side. But I would never weld in my house. I would never silver solder in my house. Unless I had really, really good ventilation that was set up right next to it. Plus, you're spending a lot more time heating up. You're spending a lot more time. You're talking temperatures of 3,000 to 5,000 degrees with welding, and with soldering, silver soldering, you're talking, I think, 1,200, 1,300, 1,500 degrees. No, it's actually higher than that. Well, no, not the soldering, but the annealing is hotter. And with the soldering iron, you're talking I think it's like 500-600 degrees Fahrenheit, but like 350 Celsius. So you're talking hundreds of degrees versus thousands of degrees. So there's a lot different as far as vaporizing the materials, what you're breathing in. But with this flux, we want to just treat it like it is. It's a toxic substance. So we're going to have to figure out, if you guys don't have spaces you can solder in. I think the hardest part is going to be people that have apartments. If they have smaller, you're not going to accumulate a bunch of smoke, but you do want to blow it out of the way with a window open kind of thing. So just make sure you guys are doing a lot of ventilation. And if you can't and you're not doing it safely, then we need to figure an alternative. I don't want somebody doing this unsafely and breathing stuff in. Okay, let's just see what else he's
already
talking
getting
about
sick
here.
and I didn't want to add to it. So, yeah, I really want to try and look after my health, particularly since we're so busy, I can't afford to get sick.
Even though the negative effects of breathing in solder smoke may not become apparent for many years, it's only sensible to do what you can to reduce your exposure by controlling this hazard in some way. Now, there's a lot of great products out there that you can buy to suck up the smoke and filter the air through carbon mats. But of course, they cost a lot of money, maybe between $50 and $100. So what if you're on a budget? Well, I asked Kathy what she's done to reduce the chance of breathing in these soldering fumes.
I bought a little fan. So it's got the fan on it with a high and low speed, and it's also got a light, which is really handy, and then I can see what I'm doing. And it's battery operated, so I don't have to run around looking for a PowerPoint. So it's really handy, and I can set it up however I want.
Now, there's so many fans out there and exhaust systems that you can buy. You might even want to jump on the internet and get some ideas of building your own smoke filter. So let's sum it all up. To minimise the risks when soldering, you need to solder in a well-ventilated area. And of course, this is going to minimise the risk of inhaling that flux smoke. Protect your eyes, because when you're soldering, sometimes the solder can spatter. And also you've got those smoke or the chemicals, you don't want those washing over your eyes either. And also wash your hands well after the project, and especially before you eat anything, because you want to remove any traces of lead from your fingers. So by following these simple steps, you're going to reduce the risks that are associated with work.
So again, we're not using lead solder, but I think all that stuff really applies. So if you're worried about the space you have, I'm not worried about my own space. I've got plenty of space. It dissipates I'm not soldering so much that if I did a couple beads on my welder, I'm going to create a cloud of smoke in my studio. If I solder 200 pins in my studio, I'm not going to get any smoke. I'm not going to get this accumulative smoke cloud. But again, you don't want to have it in your face. You don't want to work in a small room. So if you have any more concerns about your safety, because I can't really see your space and I can't regulate your space. So you guys are going to be responsible for being responsible about your own health. This goes with metals and chemicals. Some of these things are accumulative, so the more you use them, the more they build up, and you might not realize it. And you might actually start developing allergies with metals and chemicals and things like that. So and I don't care who's teaching you, if it's me, if it's a friend, if it's some expert, you always want to trust your own, you always keep your safety in mind, because from here I can't really see what you're doing. I can't be there 24 hours a day, and you're going to be, you want to be, take your own health in your own hands. So just always be cautious when handling something that's, melting or fuming out, or it has a stink to it. Always read the warning labels on things, and ask questions to your professors and whoever's showing you the stuff. And don't just accept. Like if I tell you something and you're like, well, that doesn't make sense to me. Do you really have my safety in mind? Question me, ask me, call me out. Like Miranda just said, hey, I've welded a lot, and some of these chemicals I've gotten sick before. That's a responsible way to kind of interact with the class. So make sure that you're offering each other suggestions. Make sure you're questioning me and the process, and that you keep, take your safety very seriously, because you're going to be the only one in the end that's going to protect yourself. So I would just say go on to YouTube. If you have any concerns about what we're getting into, as I mentioned, we have rosin solder. So you could go in and type in rosin, I'm sorry, rosin flux, not solder. Rosin flux, let's see, safety or something. And you could read through some of this stuff. They talk about what's in there. And I don't know if any of these are going to show you the exact stuff we have, but they're going to be pretty close. If it's rosin flux, rosin paste flux, this is exactly what we bought here.
This rosin paste.
I don't know if there's any safety to it or what it is, but and then you guys also have a little brush, a tiny little brush. So I usually mix this stuff up a little bit to get it kind of warm. If you mix something up, it gets a little warmer, and then it'll be a little gooier, and you can use a little brush to do it. But it's gonna be cold when you first get it, I'm sure, because it's freaking cold outside. All right. What else? Let's look at, so make sure you guys have the Arduino stuff downloaded. It might be a little confusing. So when I did this, I'm just going to take you back to the first page. Let's just go to software, go to downloads. When I did this, I went to my Mac, because I've got a Mac. And then it brought me to this other page, and it said just download or contribute. I don't want to give any money. I just want to download it. And then it should go ahead and download right away in your software. I actually it took me here, and then took me to another screen, then I had to hit this again, and it was a little confusing for me of what I was supposed to hit. So if anybody had any problems, please let me know. I can kind of help you get that in there. Okay, so I downloaded that, and then I opened it up, and this is what I got. I'm going to close all this other stuff down. And this is all you get. You get this little screen. There's not too much to look at here. There's a verify, which is going to be to check your code, make sure it's okay. There's going to be upload, which is going to be putting the software onto your Arduino. New, if you want to create a new, these are called sketches. You want to create a new sketch. And then if you want to open a file or save a file. Most of what you need is going to be all this stuff up in here. And let's go ahead and take a look at the Arduino book. You guys have this. You should be able to download this. Let me see if I downloaded it. Yeah, I did. So I'll just open it separately in a bigger window. And let's just kind of go through this a little bit. I'm not going to read through this because I expected you guys to do it. I'm just going to kind of hit on the stuff I think is important. So the introduction is kind of what we're, the intro, and I guess this is, I don't know if it's chapter 1, we'll call it chapter 1. This is just kind of getting to know your tools and then the introduction, and then they're going to get into the actual code and all that. So this is where I want to start. This is a breadboard, this white piece of plastic. I don't know if they dive into it anymore. I'm going to see if there's, I think down, let me look down here. I thought they talked about the breadboard a little bit more down here. There it is. Okay, so your breadboard, let's look at what they, so the breadboard is primarily a place you will be building your circuits. The one that comes in your kit, so named because you don't have to solder anything together, sort of like Lego in the electronic form. That's confusing. So it's a solderless breadboard. You're not going to solder anything on this breadboard. You're going to solder up your little chip, your little Arduino. Then we're going to put it in this thing, and then we're going to stick wires in here to try to wire something together. And if it works, then we'll take it over to something we're going to solder. So let's see. Yours might not be the same size as this one. I think it is, but it may have a couple different holes. So it says the holes in each horizontal row, so you know horizontal is like your horizon, right? It goes left and right, are connected electrically through metal strips inside the breadboard. So if you look at the back side, and these are your pins, so there's 1, 2, 3, 4, 5 on this side, then there's a separation, and then there's 1, 2, 3, 4, 5 on this side. So when you plug into one of these 5 little plugs, these all touch. So something that you plug in here and something you plug in here is like soldering them together. If I put a wire in here and then an LED in here, it's going to put power into that LED. So that's what this looks like when you rip the back of it off. So on the back, they've got like this little spongy adhesive. If you rip that off, you'll notice that all these horizontal pins are connected. And then these on the left, where it says positive and negative, these are connected vertically. So if you look in this diagram below, if you plug in a positive cable here, like your battery, let's say you plug the positive of your battery in here, anything you plug in vertical to that is going to have that same positive or negative voltage. And if you plug the opposite in this row, so you got a positive in, I think it's the left, yeah. If you plug your positive in here, then the positive of your LED goes in here, then the negative, would go in here. And so, well, that's kind of what these are made of. So all the horizontal ones in the middle are connected. Then this side is all connected, but these, these two sides are separate from each other. So you got like, it's almost like 2 breadboards into one. You've got all these pins that are connected horizontally, all these that are connected vertically, and then there's a space, and then you have like another breadboard connected to it. So think about it like being 2 breadboards. So that says the vertical strips that run the length of the breadboard are electrically connected. The strips are usually used for power and ground connections. They refer to that as a power bus. Okay, let's see here. We just talked about that. So that's kind of what your breadboard looks like. Go back to where we were. And that's one of the main things you're going to need. Your breadboard is for prototyping. So right now we're trying to make a functional object, and we're dealing with function and we're dealing with aesthetics. I strongly suggest you figure out your function first and let your aesthetics follow. Because if you try to design, your box first, or your container, or your thing that holds your electronics first, well, it might not fit in there. It might be too large, or you might have to have a different, all your points where your buttons are and your power and the battery and all that stuff is going to be things that you have to design around. So I'd figure out your function first of your project and then figure out your aesthetics. I tend to do a little bit of both at the same time. So I'm kind of thinking about what it's going to look like while I'm trying to design it. But let's worry about function first. And then we'll take a look at what the actual Arduino is in a moment here. Okay, let's see here. And some other things you could use, I talked about the other day, are like battery snaps or battery packs, where you hook a bunch of batteries and then you plug these wires into the Arduino. Capacitors we're not going to really talk about too much, but those hold and release energy or power. Motors and things like that we're not going to get into, but we talked about that. Here are your jumper wires, they're traditionally called. So if you want to order some, you would, go over to Amazon and pull that up. I'm not going to pull that up right now. Oops. And you can find different jumper wires. The ones I gave you don't look like this. The ones I gave you have look a little bit more like these red and black ones. But they don't just have the wire sticking out. It has like a pin that's soldered on there. Diodes we're not going to talk about, except for light emitting diodes, which are LEDs. So it's let's just read what a diode. Let's read what a diode is. Ensures electricity only flows in one direction, so it keeps it from going backwards essentially. Useful when you have a motor or other high current voltage load in your circuit. Diodes are polarized, meaning that the direction that they are placed in a circuit matters. So when you use a light emitting diode, so it's a diode, so it's a piece of electronics that allows electronics to go through in one direction, and it has a positive and negative, so you have to hook it up in a certain direction. So if you forget, you can look at your Arduino book. The little leg is negative, the long leg is positive. If you ever get confused, Google it. Like Google LED leads or LED positive, LED negative, something like that. But an LED is a type of diode that illuminates when electricity passes through it. Like all diodes, electricity only flows in one direction through these components. You're probably familiar with these as indicators on a variety of electrical devices. The anode, which typically connects to power, is usually the longer leg, and the cathode is usually the shorter leg or the negative. And the way I usually remember the anode and the cathode, I don't remember things very well, except so like anode is A and cathode is C, so A becomes before C. So I usually think positive comes before negative. Like that's just how I remember it. If you can't remember it, I don't care. It's not going to matter until you need to, and you can always Google it. We're not going to worry about whatever an H-bridge is, and we're not going to worry about liquid crystal displays. We don't have that in our kit. Solder header pins. So these pins fit into female sockets like those on a breadboard. So the female header pins have the same size opening as a breadboard, which fits these little pins. They help make connections, connecting things much easier. So you want to use them instead of soldering things like wires to other things. You can actually put these directly in the breadboard itself. And then you can have it like a quick release, or it's just a lot neater and it's easier for when you're doing prototyping. Okay, potentiometers. These are like on like a guitar tuner or a guitar volume knob, where it goes from like, it doesn't turn a full 360, but it turns a little bit. So a potentiometer is a variable resistor, and we'll talk about resistors in a little bit. Basically, a resistor, let's look at the resistors first. Resistors resist the flow of electrical energy in a circuit, changing the voltage and current as a result. Resistors values are measured in ohms. And it looks like, like I think that's like the omega sign or something. It says right there, omega character. The colored strips on the side of the resistors indicate their value. And that was also part of your reading, was the resistors. I don't expect you guys to remember that part, but I do expect you to be familiar with it. It's at the end of this. So it's that color coded thing. So you'll see 1, 2, 3, 4, and this one has 1, 2, 3, 4, 5. So depending on the type of resistors you have, you can use this color chart to identify what that might be. So I think you guys have 220 ohm resistors, and you have a 10K resistor, which is a 10,000 ohm resistor, and 220 is 220 ohms. They have all sorts of different ranges of resistors, but we're basically going to use those. Back down. We're basically going to use those when our juice doesn't match. 5 volts, but we have an LED that needs 1.8 volts or something, or 2.5 volts. So when we have a power supply that doesn't match our electrical needs, we use the resistors to bring that voltage down. So we use these to reduce how much power is going through. So if I need an LED and I have a 9-volt battery, I put on resistors to reduce the voltage going to the LED so the LED doesn't explode. But what happens, these things get warm because they're sucking up energy. Just like a light bulb gives off heat, these things give off heat as well. So if you have a bunch of resistors trying to suck too much voltage, these are going to get really hot. So you try to match your voltage as close as you can, and then use resistors to reduce that voltage. And we will talk about that. Don't worry about it. And so a potentiometer or a guitar, a volume knob, that's all I can think about is like a volume knob on an old stereo or a guitar or something. You can turn it from like 1 to 10, and it goes like 340 degrees or something like that. I don't know the exact, but almost a full circle. But it doesn't go full circle. And this is a variable resistor. So if you turn it to 1, it's going to give you a certain resistance. If you crank it all the way up to 10, you're going to get a much higher resistance. All right, so a variable resistor with 3 pins. 2 of the pins are connected to the ends of a fixed resistor. The middle pin, or wiper, moves across the resistor, dividing it into 2 halves. When the external, this is a lot of words you're going to forget. Basically, it's got a dial on there, and it creates voltage. It creates a range of resistance. We're not going to be reusing those too much. Not going to talk about piezos or an octocoupler. I don't even know what that is. Push buttons we're going to use. So what you have is momentary switches. So a momentary switch only stays on for a moment. So it's the type of buttons you press that automatically pop back out. So if you think about your light switch on the wall, that's not a momentary switch. That's an on-off toggle type of switch. A momentary switch is just going to be when you push it and it's on, and when you let go, it's off. So we're going to use that on Tuesday. We're going to use our resistors on Tuesday. We're going to use our LEDs on Tuesday. And we are going to, I'm not sure if we're going to get to it on Tuesday. We're going to solder on Tuesday and hopefully get to this stuff on Tuesday, if not Thursday. Okay. There are piezos. I'm not going to talk about that, but that can be used to detect vibrations and create noises. Think about like a speaker in a way. There are other type of piezos that I'm not going to get into. There are photoresistors. So I have, I'm not going to get into that. There are, like, let's say you wanted to create something so when it got dark outside, your lights went on. So maybe you wanted to create a security light so when the sun goes down, you get a little light that goes on and you can see where you're going. Or it's a garden light. You want to create a light so when the sun goes down, all your lights go on in your garden or something. You can use resistors. It's another resistor, but it's a photoresistor. So depending on how much light comes in, let's see, so let me just read it. A variable resistor that changes in resistance based on the amount of light that falls on its face. So depending on how much sun shines on this or how much shadow is on it, it will it'll create a certain amount of resistance so that the switch is either on or off. I'm not going to talk about servo motors, more kinds of motors, temperature sensor, similar to a photoresistor. You can use that to trigger something else. So if you wanted something to, like a heater to turn on or a little light to turn on, indicating that it's really cold outside, maybe it's time to get your koi out of the fish pond or something, you can use a temperature sensor along with your Arduino, and code it up so that you can, when temperature falls below 40 degrees, a light comes on or something like that. USB cables, This might seem really silly that we're going to talk about this, but it's actually probably the most important thing we're going to talk about with Arduino. So what does this say? It says this allows you to connect your Arduino Uno or any other one to your personal computer for programming. It also provides power to the Arduino for most of the projects in the kit. So not all USB cables are created equally. First of all, the one you guys have has USB on one end. I can't remember the different types of USBs. Let's see here. Let me go ahead and open my Chrome. Oh, I'm in Chrome, duh. Let's see here. USB types. What do you know? Internet. Love it. Okay, so you've got the square end. Is that a USB-B? This is the female, but yours has the male version of it. And then you're going to use a micro USB on the other. So yours has a micro USB, not a USB-A. So USB-A is what you guys are used to. Usually it has a USB-A on one end and a USB-B, a male version on the other end. And but instead of the USB-A, it has a micro USB, not a mini. See how fat the mini is? It's got like it's more square, and the micro is more flat. So not only are there different types of ends on the, let's see, USB cord types, cable types. So can you see this type of cable that has, that's not a good picture. You've seen USB cables and they have like a little cylinder. It looks like a little Coke can somewhere in line on it. Hoping to get a picture of that. Is it this thing here? No, that's not it. I can't remember what the thing is called. Man. A lot of the pictures don't show them because they just show you like the two ends. But sometimes USB cables have this little cylinder in line on the cable. It's like ferrite or something. There we go. So sometimes you'll see a USB cable with this thing on it. That will not work. These usually will not work on your, what is it called? Ferrite chokes. Let's see, what is a ferrite choke? And you guys don't have to remember this. I just want to familiarize you guys with it so that you see this stuff, you're getting familiar with it. Okay. So a ferrite bead or choke or block is a type of choke that suppresses high-frequency electronic noise in an electric circuit. Okay, great. What does that mean? It means that that cable will not work as a purely as a data cable. It'll work to charge your stuff, but it may potentially not work as a data cable. So I gave you guys a specific cable, and it says, what does it say on it? Cable Matters. That's the brand name. That's the brand name I use because I found one that works and I trust it. So when I look this stuff up, if you need to get a replacement, I usually will look up data USB cables. So if you're on Amazon, I hope this stuff is helping you guys, not confusing you. Let's see. USB cable data. So that's usually what I search when I'm looking for a USB cable that I have to use with Arduino. I don't just grab one first I just grab one I have sitting around, and then you'll notice that your Arduino will not connect to your software because it's the wrong kind of cable. Usually your cable is the first thing you problem solve when you have a problem with Arduino. I'm gonna be honest with you guys, Arduino is a pain in the butt and it gives me a big headache. So we're gonna keep it simple, but there are 100 different things that can go wrong. You could have a period in or a comma or a colon in your code and it just won't work. You could have outdated software. You could have something like you didn't have a library or something. We're not going to get into it that complicated, but just keep in mind that if your thing is not connected, the first thing to check is your cable. So make sure you have that one cable that says cable matters. It's got a USB, micro USB on one end and a USB-A on the other end. You probably have two cables in there, right? One is probably for one's cable matters. That's the one we're going to use for the Arduino, and then you probably have another cable in your kit for the fan. I think it's a micro USB cable. I'm pretty sure it looks the same, but keep one for the fan and then keep the cable matters one for your Arduino. So you guys can probably see why I wanted you to read before I went all through all this stuff. It's a lot of information. I'm going to be repeating myself. I'm going to refer to the cables again. I'll refer to the LEDs again. It's about pounding this information in your head. So you read on it, you got a little bit. We're talking today, you'll get a little bit more. We'll do more on Tuesday and Thursday, and you'll get a little bit more as we keep going. Tilt sensor, you can probably guess what that is. So if you have something and you tilt it, a physical object, and you tilt it sideways, it can tell the orientation. Transistors, I'm not going to get into. And then this is a great sheet. I couldn't tell you what most of this means. I know that that's a resistor. I know that's a LED. I know that's a battery. And I know that's a ground. Those are the only characters I know offhand. So I don't expect you guys to know these. But if you see this type of stuff in a schematic, in a wiring diagram, you should be able to start identifying things. It's helpful, to be familiar with these characters. So when you see them, you're like, oh, those are, what are they? I don't even know what they call them. Let's see. Table of symbols. So if you see these symbols on a schematic or, a wiring diagram, you should be able to know that those represent physical things. So, this is it to the bottom? Yeah, so that this represents an LED, or this represents a resistor. And you can tell the LED because it's like going in one direction. Let's see, or is that the LED? I always get confused. That goes up there, so it's talking about the one above it. So that's the LED. I was thinking this was the LED actually, so I guess I don't even know that one. So the diode and the LED look very familiar. It just got two arrows on it showing that it's a light emitting diode. All right, cool. So that's just a place you might find some helpful symbols. Let's talk about the board. So we've got this board, and then we've got our little Palulu guy. So let's take a look at the two of them together. So for this, it says power connector. This is how you power your Arduino when it's not plugged into a USB port for power. It can accept 7 to 12 volts. There is also, let's see here. So on our little breadboard, we don't have that barrel jack, right? This is a barrel jack. This is the same as you've got a barrel jack in your kit. We talked about it last class, where it looks like a little cylinder that fits into another plug. So that's what that is. That's like a female cylinder that you put that plug in. It's called a barrel jack. Again, if you don't know what that is, and I'm using these terms, and you guys are like, what is he talking about? First, ask, and then you could also Google it. So that should look pretty familiar. That's really tiny. It's not this kind of barrel jack. It's the electronics type. So you see a power plug with a male, like, little soda can sticking out of it with a hole. And then the female is, the negative with a little pin. So normally the negative is on your electronics, and the male is usually the plug. So that's what that is right there. If you look at our Arduino, our little Palulu, our little Leonardo ripoff, there is no barrel jack, but they have something called VIN, voltage in. So if you can use this micro USB to power it, but most of you will not want to use the micro USB because you're going to hook it up to a battery or something. So in that case, you're going to want to use the voltage in and the ground to power it. I will go through this stuff again. I'm just trying to pound this stuff in your brains. So as opposed to a voltage in, they have, I thought these had voltage ins. Oh, yeah, they have a voltage in here too. So there's a voltage in pin, but it also has a barrel jack. So if you want to use a wall wart, one of those plugs that has the big honking piece of plastic that connects to the wall, it's basically a AC to DC adapter. So you can use that, and you could put an AC DC adapter in here, or you can directly wire voltage in here, and I think it takes the same amount. So what is it, like the 12? Yeah, 7 to 12 volts. And I believe that's what ours take as well. Let's see, did they tell us? Maximum operating voltage output would be 5.5. Maximum operating voltage 15. Is that the N? Specs. So that must be the in. I'll verify that. I thought it was 12, but maybe it is a little bit higher. But it doesn't matter. We're not going to be using a higher voltage than, we're going to be using like 5 to 12 volts. Probably more like 5 to 9. Okay. So that's what that is. That's the power, but you also have the voltage in down here. And then you have the USB port. This is a USB-B, I think, what we were looking at before. It's that square type of USB, not the rectangular one. That goes in this end, and then the more rectangular end would go into your computer. So uses for powering your Arduino, uploading your sketches of your Arduino, and for communicating with your Arduino sketch. So a sketch is basically your code. All those ones and zeros and stuff that tell the thing what to do and how to blink a light and how to work. So that's how you communicate. That's how you get the code on here. Ours has a micro USB, and it's the same thing. The great thing about these little Leonardos is it has the software already built into it that you can communicate via USB. Not all of them do. Some of them you have to install other software, and like these are really nice. They're really simple compared to some of the Arduinos out there, even like the minis or the Chinese clones. Okay, there's a reset button right here on the Arduino Uno. I don't remember if we have one. I thought we did, but I don't see it. Let me grab mine here. I can actually... Nope, no button on there. So big deal. I never use the reset button anyways. There's a TX and RX light LEDs. These LEDs indicate communication between your Arduino and your computer. Expect them to flicker rapidly during sketch uploads. So when you're going to actually put the software on your little Arduino, these little lights should light up. And you can see those are the same thing you have here. When you first put your Arduino, you guys all have brand new Arduinos. They should all be in little packages. I may have taken one or two out of the package, I can't remember, but they're all brand new. And when you first hook your cable up to, one of these lights is going to blink. And until you put your software on, once you put your software on there, it won't blink anymore when you first plug it in. So if you get blinking on here when you first plug it in, you know it works, you should all be good. Once you put code on here, don't get freaked out if this thing doesn't blink anymore, because it won't until you hook it up again. Okay. Digital pins. Use these pins with digital read, digital write, and analog write, analog read, or analog write, analog write. Works only on these pins with the PWM symbol. All right, so that shows you your digital pins are all these through here. See PWM. And then these are your analog pins. Use these pins with analog read only. So if you look here, we've got, which ones is it? I can't remember if these little symbols on here. I don't remember the difference between, here's the analogs, and then the rest of these would be your digital. We'll go through what that means, but just know that these numbers on here, 0 through whatever, here we got 0 through 9, 10, 11, 12, and then these AO, A1 pins. These are going to be the pins that you use to plug stuff into. So you'll plug things that you need to power, like LEDs. You'll plug in sensors and motors, and that kind of thing into all these pins. So don't worry about what digital and ground pins mean at this moment. It's not a big deal for what you guys need to do. We'll follow our instructions, and they'll tell us which pins to use. And then you'll get a little more familiar with why they're called analog and why they're called digital. Okay. The Atmega controller, the heart of the Arduino Uno. That is this big black chip right here. They tell you any more details, like which one it is? They don't. And ours is on the back side. And it tells you what kind of chip it is. Let's see. It's got the Atmega 32U4. That's actually kind of a special little microcontroller that allows you to do some things that the other ones will not. So this Arduino I gave you, in my opinion, is the most efficient, has the most pins, it has the right chip, and it's the smallest you can get. There are smaller ones by just a little bit, and they can't do the same thing that this one can do. So I think this is the best bang for the buck on any Arduino project you're going to do. And if you have to jump to a bigger one because of using shields and more power or more pins or something, then you'd probably use the Uno. But I only use this and the Uno, the big one. And I don't use the big one very often because it's huge. It's like the size of your breadboard. I mean, it's not that huge considering it's a tiny computer, but compared to this tiny computer, it's pretty huge. So all this stuff is pretty much the same as your, how much does this one have? This goes up to 12 and then 2 analogs. And this one has 1, 2, 3, 4, 5, 6 analogs and like 13 digital. So it's not much. It's really close. This thing's got a lot of power for as tiny as it is. Okay. And then I told you guys to skip this part, right? Because this was about a different thing. We don't have this piece of cardboard. It's like a starter kit, and it comes with a little mount. Just ignore that stuff. We don't have that in ours. All right. So now they got the installation, Mac installation. You guys should have been able to do that on your own. And now, now that you're installed the Arduino IDE, and make sure your computer can talk to the board, it's time to make sure you can upload a program. So this is where things get exciting and frustrating all at the same time. I can almost guarantee the PC people will not have a problem, and I can almost guarantee that Mac people will have a problem. So I have a new computer. I just uploaded Arduino. I don't know if it's going to work. I've got a Mac, and so I purposely did this so that you could see exactly what I'm seeing, and we can take a look and see if we have the same problem. So I'm going to take my cable, and I'm going to plug it in. I got a Mac, so I got to use an adapter because they have micro USB-C. It's like that tiny little guy in all the Macs. PCs have it too, but it's pretty obvious because Mac just turns off everything except for these stupid little cables. Okay, I'll plug mine in. And mine doesn't flash. So yours will flash because yours is brand new. Mine already has code on it, so it's not going to flash. And I imagine we're going to run into problems right away. And you guys, while I'm talking, once you get this stuff out so you can plug it in and you can see if yours connects, because I'm going to have to ask you guys who's having problems and who's not having problems. and then I'm going to have to research those issues over the weekend. I didn't want to do it ahead of time because I wanted to see how many people actually had problems. So we're going to open up Arduino. I'm going to close everything else down just to reduce any confusion. Okay, so this is your sketch. This little bluish green header and this big white open notepad is essentially what this is. It's a text document. There's nothing special about it. It's just basically a text document. And this is where all your information is going to be. Let me go to the book again. So I'm going to go down to our assignment. I'm going to just pass it. I guess I did not pass it. So we're going to end up doing Starship Interface. And Starship Interface, I'll read through it in a little bit. But you basically have your Arduino. You have your breadboard with all your stuff. Our Arduino is actually going to plug into the breadboard itself. So we're not going to do this thing where we put it over here. We're going to actually put it directly onto our breadboard. And then the code, our sketch is going to be all this nonsense. So you basically set, let's look through this a little bit. So remember, this is page 38. And imagine this being on the left side of a book. And this is page 39. Imagine this the right side. So if you see these blue areas, they go to the left, and then they coincide with these blue areas here. So I'm going to read, the if statement. And it's talking, pin 2 and storage value, blah, blah, blah. If you follow this over, it's this first blue area. It's talking, this is it here. The second big blue area is this stuff right here. And then the last big blue section is this stuff right here. So it's telling you what all this stuff means. And I'm not going to go through this right now, but there's an if statement. Then you build up your own, it says build up your own Starship. And then you can actually run the program and then start seeing how these lights flash. So let's go up a little higher here to the first part. Okay, I'm just going to read through this. Some notes before you start. Every Arduino program has two main functions. And trust me, guys, I don't understand most of this. And I can't get this stuff into my brain. But I can read, and I can follow directions, and I can get this to do some stuff that I want. So you don't have to be an electronics expert. You can be an electronics dummy like me. I love it, but I don't really understand it. So don't feel like you have to get all this stuff. And remember what the loop is, and remember what the setup is. You don't have to remember that, but hopefully if I expose you to this stuff, it should help you figure this stuff out. So functions are a part of a computer's program that runs specific commands. Functions that have unique names and are called when needed. So like they're used when needed. The necessary function in an Arduino program are called setup and loop. These functions need to be declared, which means that you need to tell the Arduino what these functions do. Setup and loop are described as you see on the right. So it talks about the right, so it's talking about this blue area right here. Let's go down to the page below, and here you see void setup, and it's got the parentheses, bracket, end bracket, void loop, parentheses, bracket, end bracket, or the curly brackets as they're calling them. So that's the first part of your code. Let's see. To the right. In this program, you will be going to create a variable before you get into the main part of the program. Variables are names you give to places in the Arduino's memory so that you can keep track of what is happening. These values can change depending on your program's instructions. Personally, I just started to glaze over because all those words confuse me. So I'm going to keep reading and maybe something will stick. Variable names should be descriptive of what value they are storing. For example, a variable named switch state tells you what it stores, the state of the switch. On the other hand, a variable named X doesn't tell you much about what it stores. So this is where we start telling the Arduino what the pins are supposed to do. And when something's hooked up to it, is it considered on? Is it considered off? Think about ones and zeros, right? Code all ones and zeros. Yes or no, on or off. This is where you set all that basic stuff. So you're telling your Arduino what tools it has to work with. That's kind of where you start with your setup. To create a variable, you need to declare what type it is. The data type int, sorry, I lost my place. Int will hold a whole number called an integer. If you guys remember math class, integers are whole numbers, not 1.5, not 1.75, but 1 is an integer. That's any number without a decimal point. When you declare a variable, you usually give it an initial value as well. The declaration of the variable, as every statement must end with a semicolon. I'm totally lost. Don't worry about it. It's just showing you, telling what they're talking about. So switch state is 0. So it can only be on or off. So it's only going to be 1 or 0. So it's not like kinda on. That's like being kinda pregnant, right? You can't be kinda pregnant. It's either yes or no. And so that's what your integer is. It's a whole number. And the same thing down here when you're talking about your pins. These are going to be whole numbers. They can't be in between pins or something. You can't go in between floor 5 and 6. You can either go on floor 5 in a building or go onto floor 6. Okay, so integers. The setup runs once. When the Arduino is first powered, this is where the configuration digital pins to be either inputs or outputs use a function named pin mode. The pins connected to the LED will be outputs and the switch pin will be an input. Don't worry about that stuff right now. Just know that the setup is where you tell the Arduino, okay, I'm going to use your pin number 3 to do something, and I'm going to call it something. So that's where you tell because the Arduino is stupid. It's dumber than a newborn. It can't even communicate. It can't yell at you. It can't cry. It can't talk. It can't do anything. It can't even poop. It can't do a damn thing unless you tell it to. So you have to tell the Arduino where its mouth is, where its feet are, what it's going to do essentially. And then the rest of the loop is going to run while the program is going, and it's actually going to run things. But the setup is like you setting up the definitions for your stuff. Okay, create the loop function. The loop runs continuously after the setup. So the setup starts, tells the Arduino what pins to use and what to use them for, and then setup runs the whole time you're using it. It's where you check your voltage, the inputs, the turn outputs, turn outputs and on and off. To check voltage level on a digital pin, you use the function digital read. So that's telling you that, okay, above I told you which pin to use. Now I'm going to tell you what to do with that pin, and you're going to use it as a read. So that a read is going to take information, data. It's going to, those light sensors. It's going to tell you how much information is coming in on a read, and then let's see here. Okay. Arguments are information that you pass to functions, telling them how they should do their job. For example, digital read needs an argument. Which pin to check in your program? Digital read is going to check the state of pin 2 and store the value in a switch state. If there's no voltage on the pin when digital read is called, the switch state variable will get value of high or 1. If there is no voltage on the pin, switch state will get a value of low or 0. So in order for the Arduino or the little computer to know how to talk and to communicate, it has to know what those things mean. So you have to basically give it a language. And so when power comes into something and you're getting a reading, it knows that when you're getting a reading on something, that's considered, let's say, on. And when you're not getting a reading or a low reading, it's considered off. So all this explanation is really just telling you what the code is about. So we're not going to write our own code. We're going to rip off the code they gave us, and then we're going to adapt it a little bit. So there's really nothing to be scared of. All you got to do is follow directions, and there's not a lot of troubleshooting. The only troubleshooting you're going to have to do is figure out why your Arduino won't talk to your computer and plug in the right chords for the most part. You shouldn't have to do any problem solving on the code itself, because we're not going to write our own code. We're going to steal somebody else's. Okay. It says the if statement above. Oh wait, did I cover? No, I didn't cover this. Above, you use the words if to check the statement of something, namely the switched position. An if statement in the program compares two things and determines whether the comparison is true or false, 0 or 1. When it performs action you tell it to do, when comparing the two things in the program, you use two equation signs, equal, equal. If you use only one equal sign, you'll be setting a value instead of comparing it. Again, don't worry about what that means. I don't even know what the hell they're talking about right there. I do a little bit, but I don't understand it enough to actually explain it to you. If you guys are interested in this stuff and you want to take it to a higher level that I'm going to show you, Nathaniel Stern teaches a class where this is all they do. It's all Arduino and programming and Python. I don't even know what the hell they do. They do a bunch of different stuff. I'm doing the baby steps. I'm taking you guys intro, and I'm not even making you guys go all the way in on the introduction level, because there's a lot of information here that to most of us art students is super confusing. Digital write is the command that allows you to send 5 volts or 0 volts to an output pin. The digital write takes 2 arguments, what pin to control and what value to set the pin, high or low. If you want to turn the LED on and the green LED off instead of your if statement, your code would look like this. And so that's where they take you to the right here. So you can see if switch state is low or the button is not pressed. So if the button's not being pushed and it has no voltage going through it essentially, pin number 3 will be on. So your green LED will be on. Pin number 4, which is a red LED, will be off. Pin number 5, which has a red LED, will be off. So just when you turn your Arduino on and it's plugged in and it's got all this code on it, and you got a button and a bunch of resistors and a bunch of lights, if you do nothing, it will have a green light on. If you press the button, I think it does the opposite. The green light, yeah, so if the button is pressed, the green light turns off. The other red light is off, and the other red light is on. And what's going to happen is you're going to get a delay, which is, it says wait for a quarter second. So 250 is a quarter of a second. So 1,000 would be a second. So you start to see they're associating numbers with other things. And so what's going to happen is it's going to stay on for a quarter of a second, and then it's going to turn off. So you start telling these pins what they're supposed to do, how they're supposed to read the information you're giving them, and then what that information is, I think is how I'm going to best describe it. Okay. Okay, so it says after setting the LEDs to a certain state, on or off, you'll want the Arduino to pause for a moment, a quarter of a second, or I don't know if that's 250 milliseconds or what that is, for a moment before changing them back. And that's what that 250, it did it on for a bit, then it turned it off. If you don't want the light, if you don't wait, the light will go back and forth so fast that it will appear as if they are just a little dim, not on and off. This is because the Arduino goes through a loop thousands of times per second, and the LEDs will turn on and off so quick that you can't perceive it. The delay function lets you stop the Arduino for executing anything in a period time. Delay takes an argument that determines the number of milliseconds before it executes the next set of code. There will be 1,000 milliseconds in 1 second delay, so 250 is 250 milliseconds or a quarter of a second. So again, you might not know what the hell they're all talking about, but you can start to understand that if you change this delay from 250 to 1,000, you're going to get a longer light flicker, or you're going to get the light to stay on longer. So what we're going to do is we're just going to put this code in our Arduino, get it to work, and then we're going to play with it. I think that's about as much as I want to talk to that. So that's what this is in your sketch. Your sketch is what you see here in this blue. If switch state equals 0, void setup, void loop, that's those three main components of your sketch. And that's what you're going to see here. So right away you see void setup, void loop. And so if I knew what I was doing, I would type some stuff in here, and I don't though. So what I'm going to do, let me see if it's in here. It should be in here. Tools, let me think here. I'll have to check and see where it is. I haven't done this in a while here. Open recent sketchbook exam. Okay, so under file, there's sketchbook, and then there's examples. So let's see where it is. So you can see that. You go examples, starter kit, basic kit. Is it still in here? Spaceship interface. It's the first thing. If you click on that, you are now done with your Arduino code. You don't have to do a damn thing. It's all right there for you. If I hit this little check mark, it'll verify done compiling. Everything's good to go. So let's just look through this a little bit. If you see this stuff that's kind of in gray, can I make this bigger? Yeah, there we go. You see this stuff that's kind of grayed out? That's stuff that does not affect your code. Can I scroll all the way over? I guess that is. So that's the stuff. You see a little slash there? Anything that's written after that slash is going to be grayed out. So when you see that, you know it's just instructions. So what does it say? Parts required, LEDs, push button, 10K resistor, 220 ohm resistor. So it tells you everything you need, and you should have all of this in your kit. It gives you the Arduino website. It tells you who made this thing up, and it tells you what it does. Create a global variable to hold the state of a switch. This variable is persistent throughout the program where you refer to switch state. You're talking about the number it holds. Integer switch state equals 0. So what that means, the only thing that's doing anything is this little line right here. Integer switch state 0 is telling basically the switch that when nothing is being done, it's off. And then you have the void setup, which is what pins you're going to use. I'm going to use pin number 3 as an output. So that's going to give me 5 volts or 3 volts, depending on, I think it's going to be 5, depending on what you set. So it's going to have voltage going out of pin 3, 5 volts going out of pin 4, and 5 volts, or pin number 5 is also going to be an out. 3 of these pins are going to light up lights. And it tells you, declare the LED pin as an output. So you have to tell the board which pins you're going to use. So if we have our little Arduino here, and what does it say? Pins 3, 4, and 5. 3, 4, and 5. So each of these pins is going to get hooked up to one of the legs of that LED, directly or indirectly. But those will be hooked up to to some of those pins. That'll be the power supply. So the power is going from your computer to your Arduino, And depending on which of these things you hit, and depending on what this is set up to be, when you start the program, power will go from these pins out to your, I believe it's 5 volts, out to your LEDs. And then you have an input pin. So that's going to be, this should just be the switch, I think. Yeah, there's no other inputs. Okay, and then the void loop. So this is going to be what the hell the thing is doing. So it says read the value of the switch, digital read, which we did above, right? Checks to see if there is any voltage on the pin or not. So the digital read is 2. If the button is not pressed, turn on the green LED and turn off the red LEDs. So it should look like this. When the switch state is off or low, so the button is not pressed, then 3 will light up, 4 and 5 will not light up. And it says this else is part of the above if statement. Don't worry about that, what that means. If the switch is not low, or if the button is pressed, turn off the green light and blink the red lights alternatively. So this is pressed, the green button turns off, the red pin is off for a certain amount of time, and the red pin is on for a certain amount of time. And it tells you right here what that time is, 250. So it's a quarter second before choosing the light. And that will turn on, pin number 5 says low, wait for a quarter second before changing the light and turning it on or off. So this is like, basically, what are you using? What are those things? What are the function of those things you're using? And what kind of action do you want it to perform? That's the basic 3 things in your sketch. I couldn't write a piece of code to save my life. I couldn't write one piece of code right now in front of you guys. I just don't know where the commas go. I don't know when you need a parenthesis versus a bracket. I don't know this stuff well enough to do it, but I know enough to make us dangerous and let us put some lights on. So it's going to give an effect to your static object. Instead of just having a sculpture or a piece of jewelry, you're going to create some more interactive functions using lights, electricity, switches, sensors. It's just a way to be more interactive. Some of you are going to hate this. Some of you are like, I never want to hear the word Arduino again. And then that's okay. You don't have to spend as much in the Arduino on the making of your thing. So if you're a metals person, and you're into metals and you get into this, some people like it, some don't. You can decide, well, maybe let's put more metal work into my assignment and less electronics, or I'll do more 3D printing modeling and less electronics. You don't have to do all of this for your final project. I'm showing you what the possibilities are for our little mini project that we're going to create, and then you'll use that information to decide how deep into the rabbit hole you want to go. So some of you guys that are thinking about sensors, turning things on and off, writing your own custom piece of software, just consider what it takes to turn a couple lights on and off. All of this code is just to turn something on and have it blink. So if you want to create a computer that, you know, is a cell phone and it reminds you to check your dog's birthday on, you know, every other year, and you got this complex information you want to create, maybe this is not the project for you. Maybe you want to start it off with something really simple, like an indicator light. So when there's a battery in it, you know it's on and you have a little power switch. So David created something, he showed me at the end of class, that it's he created the electronics for a cement mixer to turn on. And he hits a switch and it's on or it's off. And I just indicated that it would be nice to have a little LED on there just to know that the machine is on. So even if you do that for your project, maybe you have a brooch that just has a little light to, and it just to let people know that the thing is on or doing something, or maybe it's a light that lights up a sign that says hello or something like that. That's totally fine. You can go that simple. You do not have to go this Arduino route, but you will go through the Arduino exercise, and we'll work on a mini project for the Arduino, which is the Starship interface. Okay, so that's the basic sketch, and I'm sure some of you are just like crying softly or loudly, and some of you are confused. Some of you are above this and know how to do all this stuff, but that's the basics we're going to start with. We're going to load a sketch that already exists, and the only thing we're really going to troubleshoot is our hardware. And I'm going to show you how to do it, and there are also tutorials. So let's go to YouTube. My favorite place to be. And we'll go Arduino Starship interface. That's what that thing was called. Hey, what do you know? Starship interface. I followed this guy. Looks like Frank from American Pickers. These are really good. This is, I think it's actually, it's not by Arduino necessarily, like the people, but this guy does all of them. He's clear, he's articulate, he shows you, he describes basically what I just told you. We could have actually watched this video, and then he goes through the code. And so when you guys actually do this, review this video, check this out, try some other ones. Maybe you see another exercise. Maybe you want to create one that's not in the Starship interface and you want to create one on your own. But you can see tons of people have done this exercise. So if you want a better look at the electronics and you want a better look at what's going on, except for this silly paper thing that they put on it, we don't have this silly little paper. It's like the dashboard or something. I don't think it's necessary for what we're doing. Everything else is the same. So lots of information. It hurts me when people tell me they can't find information on the internet. If it's a complex search and they don't know what they're looking for, I definitely get it. I absolutely get how searching can be a bit of a pain. But if you just practice and you choose the right words, searching is even better than it was 5 years ago, definitely 10 years ago. You had to be more specific or not too specific. Now you can, you can talk to your computer and it'll look up stuff for you. So don't be afraid to go on YouTube. I want you guys to go on YouTube. It's going to be a requirement. You guys are going to have to do individual research and things, look up projects. If you're going to want to create a belt buckle that throws out light, then you're going to want to look on here and try to find somebody that already did that project. When I did the Arduino keyboard shortcut, I didn't know what to call it at first. And then once I searched for, I think I looked for like remote keys on computer, and then I saw a video that talked about keyboard shortcuts. And then I found a bunch of videos on hotkeys. And then so I tried it with hotkeys, and hotkeys seem to be the thing to search. And then maybe I want to put in tutorial, because I want someone to walk me through it. I don't want just someone to show me the cool project so I can be frustrated at not knowing how to do one more thing. I want a tutorial. I want someone to take my hand, tell me everything's going to be okay, and show me how to do this stuff. So, this would be a place you could go on here. You could look through, look through the description, make sure they got the code. Oh, there's the code. So they've got the code. They've got pictures of how to do the electronics. This might be a good one to use. I used a different one, but whatever. This is how I did it. Okay. You guys doing okay? I haven't heard anything. I saw you guys talking a lot. I just want to make sure you guys feel okay. Any questions, or does anybody want to interject and say something? You guys doing okay? All right. Oh, yeah.
I don't know how to say this, but I actually forgot my toolbox today because I'm in a cabin. I'll be able to do that part of the assignment. So today,
You can't do what part?
Isn't this exercise like using like the tools from the toolkit?
I mean, class is going to be over in an hour, so we've already been sitting here for an hour and a half, and we haven't even touched anything. We can't do anything until we solder. So Tuesday we're going to solder. And today we're just plugging in the Arduino to see if it works. I'm not too worried about getting anything. We're just problem solving right now. So if you don't have your Arduino, you're just not going to have the experience of plugging it in. So it doesn't matter.
Okay.
Anybody else?
Thanks. I was
Yeah, no
worried
problem.
about that.
Yeah, no problem. So guys, just make sure you have your stuff. I know it's kind of easy for me to say that because you're coming into class not knowing what we're going to be doing. Try to be prepared. Have your, have your toolkit handy. If you're working somewhere else remotely and you don't have it, then just make sure that you're watching the video. If it's not posted in time and you're waiting for it, make sure you send Paul an email, ask him if he can post it. But he's really good on getting these things posted, and you guys can take notes. There's no reason you can't take some notes. I know it's hard on all this information, but I haven't actually given you anything to do yet. So you guys should be okay. Anybody else? Questions, concerns? Anybody else want to, their heads about to explode? All right, cool. So we've got our code in here, and I don't care if you guys are doing it separately. We're going to do this again. We'll probably do this 2 or 3 times. But you can just kind of follow with what I'm doing. So I've got my Arduino hooked up. It's plugged in. It's plugged into my computer. It's not flashing. Yours will flash. Mine is not because I've already got some code hooked up onto it. So I hit the verify, and that's going to tell me if the code is, not that if the code is any good, but it's going to tell me if there's any errors in the code, like I'm missing a semicolon, or if I have a typo, it's going to say, I don't know what the hell you're talking about, so fix this line. And that'll tell you all that stuff down here. So the code looks good, and it better be because Arduino is the one giving me this code. Let's go see what else is up here. So Arduino, we got about Arduino. That's going to tell you what version you have. Preferences, like some settings, service, no idea, and quit Arduino. File, you can open your sketch. You can open a recent sketch. Let's say you were working on something, so you can see I've got Nixie, Suzuki, some stuff I was working on for a motorcycle, some different things that I was working on for different projects. It's like so if I want to open a project I already created, I can do that through Sketchbook or go through Open. Examples there's so much stuff in here, it's crazy. So what we did is we went through number 10, which is the starter basic kit. So that book that I gave you guys, everything in there is in the Arduino program. So if you want to try with the level meter uses a heat sensor. So when you put your finger on it, depending on how warm you are, how long you have your finger on that sensor, it'll turn on LEDs and it'll say like, ooh, you're a super lover. It's like an old meter machine from like, the 20s and 30s and stuff, or maybe not that early, but it's like a carnival type of thing. It tells you how passionate you are. All it is taking your temperature. It's kind of silly. If you want to try working with servo motors, you can open up these and go on YouTube all these. Type in Arduino, the name of these, digital hourglass, and you'll get that you'll get a tutorial by that Frank looking guy or 100 other people that will show you what you need and how to run these other tutorials. So if you're going through the Arduino handbook and you found a different exercise that you're interested that is close to what you want to make, so maybe you want to make a belt buckle that when somebody puts their hands on it, it'll light up. You could use that Love Meter software and just change it slightly to create what you need it to. Maybe hook up 5 LEDs instead of 1 LED, or have it come on for 5 seconds instead of 1 second or whatever. But check out those other examples up here in File, Examples, Startup Basics. But there's also a bunch of other ones. There's other type of basics. So if you want just to learn how to make a light blink, just a single light blink, there's one here called Blink. Actually, I think this will make your LED on your Arduino blink. I could be wrong, though. Let's see what else we got in here. Close, save, all that standard type of stuff. Edit, I can't think if I use anything in here. I guess like copy and paste, but that's about all I use in here. Sketch is going to be where a lot of this, sketch and tools. So sketch is going to be verify or compile. That's going to be this check mark I hit here. Just to, before I actually upload my sketch, I'll verify it just to make sure I don't have any typos or any obvious errors in it. Upload is going to be this little green arrow or this little arrow right here. The shortcut is over here. That's going to be to upload this software onto your Arduino. Include library is something you might have to use. So if you have a little program that is already in here, include library. So if you want to use steppers or God, I don't know what some of this stuff even is. You're going to need certain libraries. So if you have to write certain code, it's going to tell you, oh, make sure you include, this is a pretty, where is it here? This U8 GLIB library. That's something that gets used pretty often. So I had to download that library from Arduino. Otherwise, my sketch wouldn't work. Don't worry about that stuff right now, but this is when you start reading about libraries and managing your libraries and updating your software in Arduino, this is where you do some of that stuff. But for the most part, I guess I don't really do much in Sketch. I guess the stuff I do in Sketch is these shortcuts right here. So tools is where it gets funky. Auto format, I have no idea. Archive sketch, I have no idea. Fixing, coding, reload, never used it. Manage libraries, yeah, I've used it. It's when you want to update some stuff. So maybe you want to use Adafruit and you want to use one of Adafruit's boards. Well, Arduino does not automatically have an Adafruit board in here because you have to tell it what board you're going to use. And so you can get these other libraries. Is that what they're calling them, right? Sorry, I'm on Teams. That's what these other libraries they are. Okay, serial monitor. It's going to open up. Oh, maybe we can't do it through here. Serial monitor is going to open up a little white screen, and it's going to, if you're doing a test, like let's say you're taking a temperature, or let's say you're taking temperature, so you've got a little thermo sensor that takes the temperature. That little window will read what the temperature is. It'll read what the program is doing. Library, serial port, serial plotter, I don't know. Wi-Fi, okay, don't know. This is what we're looking for right now. So you want to be able, between your board and your port. Let's go to port. So for people that have their Arduino hooked up, you will or will not see this other stuff. So you're going to see Bluetooth. Doesn't do you any good. What you want to see is Arduino Leonardo. You want to see another port in here, a USB port in here. So if I click that, that should allow me to connect to my board. Let's do that again. Sketch, I'm sorry, tools, port, and you should see something besides USB. So if you like, let me unhook mine and do it. So if I unplug my Leonardo, I can't believe it worked. That's so exciting. If I go to port, see, I only have one option, and it's Bluetooth. That's always there. I don't know what that is, but that's not what you want. You want a USB port. So see how there's only one thing listed there, Bluetooth? That tells me that my computer does not recognize that my Arduino is hooked up. So first thing you do is make sure your Arduino is hooked up. Second thing you would do is check your cable. Make sure you all have the correct cable if you picked up a kit. Okay, I'm going to plug mine back in, and I'm going to cross my fingers and pray to the Arduino gods that it recognizes my board or my port. Thank the Arduino gods. There's my port. And it might be checked for you automatically. If it's not, then click on that. And then you're going to go to Tools, and then you're going to choose your board. Right now, mine's an Arduino Uno, but I'm using an Arduino Leonardo. Even though it's technically not an Arduino, it's a Polulu, it's a different brand name, it's a Arduino Leonardo clone. So that's the thing you want to choose to recognize that little driver. And so I should be hooked up. So I'm going to just hit upload and hope that it works. I'm going to watch down here. Good sign. Uploading. Sweet, sweet, sweet. Sweet. Keep going. I don't want to see any red. Done uploading. It works. And it's funny because some of the things that I have hooked up on my Arduino, this is the thing I have hooked up is for the thing I tried to show you the other day that wasn't working. It was that electromagnetic field sensor. And I still have those same wires hooked up, and it's making my LED blink. So I must have had some of the same stuff hooked up. So did anybody try hooking their Arduino up and not have it work?
Mine didn't work.
Who's mine? Who's saying? Paul? Oh, what kind of computer do you have, Paul?
I have a Mac.
Okay. And you're using that cable
that
I gave you?
Mm-hmm.
And you have no port, correct?
All I see is Bluetooth incoming port and my AirPods.
Okay. So we're gonna have to figure out what the heck is going on yours. So if you could let me know, maybe send me an email. And this goes for everybody. So anybody not having their stuff work, I want you to go up to, it's probably just Mac people. I want you to go up to your little Apple and go about this Mac. And I want to know what you're running, what version of, if you're running Catalina, I want to know what version of software you're running. And like which MacBook. You know, if you can give me information, is sometimes they tell you the year. Like mine says 13-inch MacBook Pro 2020. So let me know which MacBook you have and what software you're running, and then I can troubleshoot what the problem might be. Is there anybody else that has that same problem? So in the comments, oh, somebody coming on to say something? Oh, okay. So in the comments, I want to know who was able to, who's got their Arduino plugged in. So so for your name, just type a comment, say plugged in, not working, Mac. Plugged in, working PC, or whatever. Just let me know that it's working or not working, or just simply not plugged in. Maybe you don't have it plugged in at all. Perfect, got it. Plugged in, not working Mac. So Paul, I already told him he's going to send me his information. I have a Mac. I'm a step behind, not plugged in yet. No problem. Check it out. If you have a problem, then just send me an email letting me know those three things. This is for the Pulu board, correct? Yes, the Pulu board, but you're going to call it a Leonardo. Okay, so some people aren't plugged in yet. They're not really ready to check. So it looks like we had one or two people that are plugged in, and it won't work for them. So send me your version of your software, what kind of computer. It's probably a Mac, and then what kind of computer you have, a MacBook Pro, what year it kind of is. So then I'm just going to go on to, let's do Paul's, for instance. Let's see, Arduino, Mac. Paul, what are you running? What software are you running?
Same as yours.
Okay. Oh, really?
Yep.
Damn it.
It's a 2015 though.
Okay. Cat. So when I first said I didn't think mine was going to work, that was on my 2015 Mac. So there might be something we have to do to that one. And so I'm going to put 2015 MacBook Pro. All right. Install problems. Let's say no port. No ports available. Port doesn't detect on MacBook Catalina. So that's what I'm going to do is I'm going to start looking this stuff up for next class. So I'd like everybody, and you guys can try this too. Paul, I would love it if you did this. If you went Arduino, Mac, I just typed a bunch of this stuff in and just started looking for stuff. You might be like, I don't know enough to actually be able to manage this, and you might get lost. That's totally fine. I don't expect you guys to problem solve this on your own, but I do expect you to try. So anybody that can't get this to work, do some Google searches, spend a half an hour. This is going to be your homework, is to try to get your board hooked up. If you do not get your board hooked up, you will not fail. I'm not going to take attendance on if you look this stuff up. You could lie to me and say I looked for 3 hours and I couldn't get it to work. I'm not going to test you, but I do want you guys to try. This class is all about problem solving and trying to learn this stuff on your own. It's not just about learning these programs. So I want you guys to get, into a little place that's uncomfortable and try to do a little problem solving. Some are going to say to change your chords. I don't think the chord is a problem because I gave you guys all good chords. That should not be the issue. But just try to problem solve a little bit, see what you can get figured out. PCs are all probably going to have absolutely no problem. I can't imagine PCs are going to have any problems. It's going to be the Mac people. And I'm a Mac person, so I'm well versed in problems. So let's see. Okay. Let's see if there's anything else I want to look at in here. Not really. Awesome. Great to hear. Working. That's kind of all I really want to talk about with Arduino for today. It's a lot of information. You guys read a lot of stuff. Now you probably have to go back and read more because I covered some things and you might want to go back and go, what was he talking about with the void setup or whatever the case is, so maybe go back and try to get familiar. This is an uncomfortable place for most of us. And I just want you guys to get as comfortable as you can. At least get comfortable with your being uncomfortable. If you're like, my God, I didn't sign up for this. It's not a math class. I hate computers. I don't get this stuff. You're still going to get what we got to do, and you don't need to use it on your final assignment if you don't want to. But I want to show you the possibilities that are out there. And as digital fabrication really is not its own thing, right? It's usually best when paired up with another craft. So if you guys are just doing digital fabrication as your certificate, and you don't have your major in, you're taking a BA and you don't have a BFA where you actually have a concentration like metals or sculpture or ceramics, you're not going to get as much out of digital fabrication. You're definitely not going to just get a job with a certificate. It'll help you get a job, but if you don't know how to do anything else, this little couple classes is not going to get you a digital fabrication job. It's going to be combined with the work you make, combined with things you learn in metals or sculpture or DSP or DVC or any of those other programs. So digital fabrication is really to help you put a specialty on your regular fabrication. It's something to help you with all that other stuff. And so that other stuff would be soldering, carving, sculpting, welding, metal fabrication, throwing a pot, like whatever it is. And to complement that, you're using things like 3D modeling. You're using 3D printing to maybe make a mold or a pattern for a mold. And you're making a ring so that you can cast in metal or whatever the case may be. It's usually not just about the 3D printed blob that comes off the printer. It's usually about combining it with other craft. And so one other aspect of that is programming and circuitry. So I want to introduce that to you guys. And if you don't like it, you can walk away from it after this project and never look back at it again. But I want you guys to know that this is kind of a big part of digital fabrication if you don't have a lot of other traditional fabrication under your belts. Okay, how you guys feeling? Comments, questions? Let's see, take a look here. I don't think I have anything new that we need to go through. So, oops, looks like I gotta sign back in. Nope, not doing it right now. Okay, so I got Paul's email. Anybody else that needs me to send something, make sure you send me so I can do some research over the weekend. And it is almost 1 o'clock, so I want to let you guys have a little extra time to either finish up any designs you're working on. If you got some sketches, maybe you're not ready to finish up your design because you still have to understand this whole circuit Arduino thing. But on Tuesday, make sure you guys have a place prepped to solder. If you can't talk in the same place you're going to solder, make sure you're taking notes. Remember, you guys can record your screens too. You don't have to necessarily use the recordings that Paul is doing. You can use QuickTime or whatever PC has. I don't know what you use on PC to record with, but you guys can record your screens yourselves as well if you need to get this information a little faster. So for the weekend, I want you guys to get your Arduino, that code uploaded onto it if you can. If you can't, I want you to get me an email to tell me what's not working, and then I want you to try to problem solve yourself. So on Tuesday, we're going to take the Arduino, we're going to get into the soldering, and then we're going to hook up all the electrical components and get this thing flashing some lights so we can go back to the design idea. We can look at your designs again on Tuesday and Thursday, probably Thursday, and we can refine these down a little bit more. So keep thinking about your designs, and then we're going to start getting into soldering, and we're going to get into working with some laser cutting and resin printing on the 3D printer. So we're going to learn all that other stuff before we even finalize our design, because you might not understand the possibilities that you can create if you haven't been exposed to the laser cutter and the other stuff. Let's see. What color is light supposed to be again? Which light?
On the Palulu thing?
Oh, I don't know. I don't know which light it's supposed to be. As long as you can get that to connect.
Okay, I have a yellow blinking light. I just thought it was supposed
Perfect.
to be pink for some reason.
If it's blinking and it connects, then you are good. Yeah, orange or yellow, I think is what it is. I don't think it's a red light, but it should blink.
Okay.
But once you get your code on there, it might not blink anymore. So don't freak out and think that you broke it. All right, you guys are great, man. You're using that chat up like crazy. I saw you all talking. Keep it up. I'm going to cut class short here, and I hope you guys all have a good weekend. Are there any last questions? All right. If you guys need any help, reach out to me over the weekend. Otherwise, I'm going to cut class. Thanks, guys.
See y'all later.
See ya.
Bye.
Bye-bye.